So again, my apologies for the interruption. We were about to complete the introduction. So very briefly, it will not be a sole instruction, it will be a portfolio of instructions, hopefully trying to get the right type of training. Class participants, as already Professor Olcher has said, are from all over the world, no matter of the physical location, and hopefully this internet platform, no matter of the potential drawbacks, will help us all to coordinate. Very briefly, and in order to catch up time, this is just a browse through of the course content. So currently we are delivering lecture 3.0. Let me reiterate once more that all lectures at the end of each day will be made available for you. Other titles follow. They are pretty self-explanatory, so I don't want just to repeat their titles. So feel free to look on the titles. It is a rather long course. Keep in mind it is 5 days. So basically this will take place tomorrow. More to come on Wednesday. Some practicalities on Wednesday and Thursday. And finally, the notorious exam. Keep in mind, it's not something threatening, it's just for quality assurance, or it makes sure that we all take part in the course. So, what is the expectation from the students, or how students should prepare themselves? To begin with, we all know that this might not be available. Ideally, Module 1 should have created this background. However, keep in mind that the content of Module 2, this is not a requirement. This is nice to have, not a must-have. For those that will take part in the course, because the practical element will be reinforced, it will be a necessity to have applicable certification. For you, it's not. Okay, and basically, to have some basic emergency management training and knowledge, I'm expecting that up to a level this is available from each and everyone that is taking part in this course. Now, there is an academic, I would say it's more industry-oriented textbook, which is this one. A lot of the material in the course are reflective with contents in this book. Furthermore, for those that I want to deal more, there are supplemental readings, these two being the strongest example. And of course, you cannot get away from the classification society. So basically, this is dealing with the security aspect. However, there are also important guidelines from the classification society. And if anyone wants to deal more, feel free to browse through these two important documents. Now, hopefully you had enough with the orientation. Even the UK should probably be awake by now. So, the purpose of what follows is to provide a short explanation to create a uniform background, even if you don't have previous experience with LNG or even the maritime industry. So, you can see this is a model. However, now we have evolved a lot more. These are all the key concepts. So, in order to conduct LNG operations, definitely you need infrastructure, you need to promote safety, and of course crew training, which is practically what we are rehearsing in this course. An important thing to note, public understanding in discussion is still limited. The public right now has some type of fear. If you see an LNG bunkering operation and you see some type of steam or fog, you're getting worried, is it working properly? Is this done the right way? Is it safe? To remove any worries, yes, it is completely safe. If it's done properly, let me put in brackets. So, why LNG? If you hear about energy security experts, you could see that we are coming to the end of the oil era. So definitely we need to provide an alternative, and keep in mind there are a lot of benefits. To begin with, LNG, when compared with other fuels, has a lower cost. Even more, as already the President highlighted in her introductory speech, it has a better environmental performance, or to cut a long way short, less emissions when compared with oil. And of course, we are not there 100%. There are still technological and operational improvements that are taking place at other investors or in the respective terminals. Especially in Europe, the European Union is strongly promoting the use in LNG. In the United States, based on the recent developments on emissions, there is a strong interest for LNG, either in conversion of old vessels or mainly in new builds. Especially in regions like Scandinavia or in both coastline of the United States, which follow into the SECA regime, LNG is a very good way and cost-efficient way, let me add, in order to conform with these strict regulations. The SECA is, you can find the explanation of the acronym over there. So, what is the current status? In Europe, right now, we have roughly 50 ports that can serve LNG bunkering. Furthermore, the idea is, within a rather, let's say, optimistic framework, to achieve capability in all major European ports, and by 2025, in all inland waterway ports. So the idea is that Europe will be LNG compatible in the near future. Things to note. However, through the IMO regulatory efforts, this will be alleviated. A very important element, in order for LNG to be used, it needs to be cooled. And it must be cooled heavily in order to be turned into liquid. Keep in mind, it's gas, so you need to freeze it heavily and turn it into liquid. Then you can store it in some type of tank and you can transport. This is the tank. Keep in mind that in order to use it again, you have to convert it back into gas. Energy density is roughly 60% of the diesel fuel. However, because it is compressed, you can recap some, let's say, energy that is not achieved by the total volume. And of course, keep in mind that it's typically stored in cylindrical. Why cylindrical? For uniform compression reasons, with the respective insulation, in order to maintain its low temperature, and then suddenly you have increased your storage capacity compared to the conventional fuel tanks. So you might have less performance, but you are having more fuel available. If we look into the environmental aspect, and especially emissions, so if you compare with traditional diesel engine, this is a reduction that can be achieved via LNG. Clearly there is a benefit here, clearly there is significant benefit here, and of course even the NOxes are completely alleviated. So if we want to focus into the environmental aspect, this is the main slide that we need to take into consideration. Practically, with LNG, all environmental drawbacks of fuel oil are alleviated, or at least reduced. If we look back into history, LNG is not something new. In 1959, it was the first effort. Over the years, there was an increase. Let me also say that very recently, developments that took place in Japan with the destruction of the nuclear reactor and the decision of the Japanese government to stay away from nuclear engine heavily promoted the use of LNG in the Asia region. So practically, during the last couple of years after the Fukushima destruction, tremendous quantities of LNG were transported towards Japan in order to support its energy needs. If we want to take a very quick look on the design, which hopefully Module 1 has covered the great majority of all this. So basically, this is the standard form of an LNG tanker ship. So what do you have? You have a vessel that is capable of carrying the tanks. I will not provide any more details on this issue. This was covered in Module 1 extensively. However, in order for everyone to have a uniform background, when we are talking about LNG cargo ships, this is what we expect to get. Let's also provide a short explanation of the whole LNG fuel transport process from the source up to the end user. So definitely you need some type of refinery that will load the ship. There are other means of transport such as trucks or barges, other self-propellant or with a tugboat, and they can deliver to various fuel stations if we can use this term. So for example, here we have a fueling station in land that is used in land transport, or we have bunker stations that are serving ports, or large bunker vessels in order to serve the end user. Truck, so he will go to the respective fuel station, or ships. Keep in mind, for the time being, because the infrastructure is limited, this is a rather short endurance. You cannot go to any point of the world, from any point of the world to the other with LNG for the time being. You need refueling. Infrastructure is not there yet. However, in the years to come, infrastructure will be greatly enhanced. Some examples. So basically, for ferries and short distance shipping, this is a very good example. So in the United States, in the Great Lakes, or in respective areas with short distance, so ferries. In Canada, when you have standard routes such as the service of an offshore platform, it is easily to allocate this task to an offshore supply vessel. You know point A, you know point B very well, you know the endurance of the ship, then why not take advantage of lesser emission and cheaper fuel? And of course, keep in mind recent developments. It's not only ferries that are doing short distances. You can have passenger ship, such as the Viking Grace. The Viking Grace is serving a line here between Finland and Sweden. It's not only passenger ships. Recently, there were new builds that are serving containers. This is a container ship, and this is the proposed layout for propulsion. So this is a container ship. But keep in mind, in the long run, there are only dedicated ways to make sure that bunkering is taking place. These are the alternatives. So, on the pier, via truck, or on the pier, by a dedicated vessel. If it is a dedicated truck, or if it is a permanent infrastructure in the form of pipelines, it makes no difference. Or the other way is to get a bunker vessel alongside. Similarly, like fuel oil is transport in major ports, the infrastructure is not there today. So, to recap, LNG is steadily gaining on ground. Here are some potential projects. You can see that transport capacity in the domain of container ship is steadily increasing, and very recent developments, since that now infrastructure is booming, large passengers, such as Carnival, such as ships coming from Carnival, will be using LNG as their mean of fuel. So clearly, there is a tendency to promote LNG further. As infrastructure for bunkering is expanding, so will end users take advantage of this opportunity. Because for two main reasons, lower emissions, cheaper fuel, clearly LNG holds a comparative advantage. So to cut a long way short, very recently, Carnival, and why we are using Carnival? Because Carnival is one of the largest, or the world's largest cruise ship owner, has finalized contracts for LNG, or I would say mega passenger ship, because the capacity is extremely large. Clearly, if you are willing to allocate the safety of all these passengers to an LNG vessel, I'm guessing that any fear related with LNG operation and bunkering should not be there in any place. Who others? We've mentioned Carnival. Clearly here in Scandinavia, because of the regulation of the SECA, so Norwegians are also pioneering this domain. Initially, in order to create a link with Module 1, at the end of this presentation, we will show a video of the operation of an LNG tanker. Unfortunately, when you are relying in YouTube for issues like that, the owner of the account can remove it, so it's not available. So, to cut a long way short, although officially in 3.0 there was a video from YouTube, this was substituted by supplementary material from DMVGL that will explain the bunkering that is taking place in exactly this location. So, Norwegians or the whole Scandinavia, also Western Europe is strongly promoting, Netherlands and Germany, Belgium. There are other partners, or there are different projects within EU trying to promote the use of LNG in various ports. United States were mentioned earlier. Ferries. The question here remains, however, infrastructure is expanding significantly. And we all know that infrastructure and the end user are strongly related. So as infrastructure is expanding, the end users will be more willing to take advantage of LNG. As the end users are more willing to take advantage of LNG, the more infrastructure will expand. Now, not everything is with no precaution. You need to take advantage that spills can happen. So basically, you can have a spill. But, as you will see later in this course, there are responses and ways of dealing with this type of incident. This is another issue that needs to be addressed in this course. This is why you cannot see it with your own eyes, you cannot smell it, there is no color indicated. So definitely you need special equipment to be able to deal that this is not happening. And of course, we need to think about what if a spill develops into a fire incident and what are the potential ranges. So in order to mitigate what is that this will never take place, if you don't want a fire, you don't want a spill to take place. It's as simple as that. So avoid any spill and you reduce the chances for a fire. And the terrorism issue, we will highlight, we will not deal too much. Keep in mind, those that are not experienced with LNG have the tendency to say that an LNG tanker is a floating bomb. At any case, an LNG ship is a floating bomb. The industry and IMO has taken every measure to ensure that LNG transport and bunkering procedures are completely safe. And if you apply the right security measure, everything will be safe and secure. Of course, in order to do that, you need to increase safety and risk management on board vessels and within the port. Keep in mind that LNG shipping up to date has an excellent safety record, so basically zero incident. This is a strong indicator that practices employed in the specific domain are quite safe. And of course, one of the main purposes of this course is to make sure that this excellent record will continue the same pace. Food for thought, yes, we're still not uniform in regulation, however, IGF is already in place, and hopefully these efforts from IMO will make sure that everyone is moving on the same direction. There are issues. For example, there is the need for environmental assessments. Definitely we need to make them mandatory. Public opinion, for the time being, the general public is not educated well enough about LNG. So one of the main purposes of this course is to transform you into ambassadors about LNG safety. And these are the main topics that we need to further address in order to change public perception about LNG. Is it possible to maintain zero level of accidents? Yes, it is. How? Good training and enforcing safety culture. Terrorism, hopefully we will, again with preparation and risk mitigation. And of course, we need also to discuss what is the interface of maritime transport with other modes of transporting LNG, because as we know, every time there is interaction, there is an increased level of risk. Different mentality, different language, different habits, different type of training. Reaching to the end of the introduction, hopefully we have covered, if anyone was missing some elements of module 1 with only one slide. So, I need you to focus on these issues. Yes, LNG operations, bunkering operations are complex. But if you train properly and if you employ your training right, it can be done safely. LNG demand is increasing globally. Keep in mind that for the time being, there is a significant dual fuel ships already involved in maritime transport, such as the Viking Grace. But of course, there are still pending issues. Not everything is solved yet. So very briefly, now that we're coming to an end, and hopefully that the platform will not crash, let's try to see this video. Yes, will not show.
We should do it through YouTube.
Through YouTube instead. So my apologies for that. We will take a very slow try to find the respective doing YouTube and directly.
If they can still hear us.
Oh, 10%. Fabio, can you pause? Yeah. So we log off and show them in YouTube the video.
Let them know we'll be back at 11.
Okay.
Are we still feeding?
Are we showing it now or after the break? The video, or within when they are having the break?
The video is 8 minutes long, so it's better to show it now and get over with it.
Right, have that roll into the break. So have everybody go to their YouTube,
Yes.
log in, or play that video, and then return at 11.
Okay.
Come on. So just to solve some minor administrative details.
They can see it from their computer. We ask them.
It's the first and the supplementary material.
So to them.
Yes, it's this one, the first and the supplementary material.
Okay, thank you everyone. I think we want to roll into a break here, but because video footage is not very well supported with this platform, we've asked you then to go onto your internet and find the video using the links that we provided in a separate document. So what we're going to do is ask that you go watch this 8-minute clip and then take a break, return here at 11. We'll start with the next 3.1 and carry forward. Okay? So take a break after you watch this video. Thank you.
Thank you.
Yeah. I'm okay. I'm okay. Sorry? Yeah.
Yes, we are. Should we can mute ourselves. We can.
Who the hell is calling at this hour of the morning? Hello. Hey, good morning, Jared. Okay. Yes.
surely. Okay, sounds good. Yep. Okay, Jared, good. Yep, bye. Two, three. Yes, Jared. Huh, okay, yeah, because my video, oh, okay, you've got it? Okay, fine. All right, good. All right, Jared. Okay, thank you. I can't hear you, though. I don't have any audio.
So we've muted ourselves on our end. I'm going to turn our mic off so that you have the floor. If there's anything, just chime in and ask us to come on, and we'll put our mic back on.
Okay, I can hear you now with no problems whatsoever.
Perfect.
1, 2, 3, 1, 2, 3, 1, 2, 3.
Very good, very good. So I think we're all set. We're going to turn our microphone off.
Okay. Okay, so I'm going to have this, because you've got the speakers on in the room, I've got that delay, and of course I'm talking over myself. Okay,
Right.
so that's I have to deal with.
Okay. And as far as running the PowerPoint, you can manage from your end there. I assume, right, Josephine?
Yes.
Thank you.
You
Okay.
just share his screen.
So John, you just share your screen. You share
I
it.
will share it.
So we will share your screen from our end, and then you will just flip through your PowerPoints.
Okay, lost the audio.
Yeah, they're choppy now.
I'll go upstairs and print all the documents.
Yeah, and we can call me, so we can quickly discuss.
If you want, John, you can load up your first PowerPoint. Just to have that on the screen so that we know everything works. Oh, I think we lost it.
Okay, I've got some.
There it is.
No audio, no audio, no audio. Okay, will I just be talking to myself here, Jared?
You will. You'll just be speaking into the microphone, into your headset there, and giving the presentations. And as questions come in, you can see at the bottom of your screen if there's any questions that come in. But at this point, I think we're all just kind of sitting here just the first day. Can you hear me? John, can you hear me? Can you hear us here? Can you hear me, John? Fabio, can you get him lined up? I don't have his eyes. He can't hear us at the moment.
Okay, let's see.
Just get him lined up with starting his power.
So we are the moderator and we still have the, what is he?
Call me.
Let's see now. Can you hear us?
We have, no?
We have, but
But we are using this.
we can't use this. Can you hear me now?
Okay, can you hear me?
Yeah, it's clear. Can you see me? Can you see the?
Yes.
Okay.
Yep.
I think it's okay.
Have him pull up his PowerPoint so that he's ready to go through.
So now I'm going to share the screen to you,
Okay.
so you can. Let's do that. So you can share the PowerPoint.
All right, I'm going to.
Yeah, great. So now, if you open one PowerPoint, we should see.
Okay.
Okay, great. Yeah, I can see your screen.
Okay, I have no screen.
Yeah. So now,
Some coffee?
no, thank you. It's fine right now. Yeah. If you take coffee, take coffee, but don't. Yeah. Black, whatever. Yeah. Did you have problem to?
Okay, I've got the application box. I'm going to check desktop, correct?
Yeah.
Okay, because underneath there's a bunch of different programs and PowerPoint doesn't show up. So I'm just going to click desktop.
Yeah. You just try in case we can try to open from this side.
Okay.
Okay, great.
Okay. Back again. Desktop. Accept.
Okay. Okay. Can you hear me? Can you hear me? Okay, fantastic. I can see. Yeah. I can, yeah. Can you hear me now? Can you hear me?
Fabio, this is for you.
Thank you.
Don't forget, normally we are not allowed.
1, 2, 3, 4. Okay, I do not have any audio.
Can you hear me?
For break, 206.
For break, is that what you said?
No, I'm asking you.
I don't know how much it is. You mean upstairs?
John?
We have a,
Can you hear me, John?
Come on. No, I didn't even
Connect.
very IT person, especially because we're going
I
to.
got an email, somebody who cannot get onto the program at all.
You told them once and
What can I do about that? I'm sorry.
Sorry, I still get you.
I enabled the connection.
Yes, maybe.
Wait, we gotta get Bob, we gotta get him on. We gotta focus on this. Class starts.
Yeah, but it doesn't do it. Can you hear me, John?
Is it not working now again?
No, I can't hear you. I cannot hear you.
Are you on moderation?
Yeah. Everything's. No, I'll share.
Hey,
We can hear him, so you want to direct?
I can hear you.
Yeah, let's tell him. How to pull up his PowerPoint.
Wait.
I don't know how to use the program. Just tell me how to put the.
Hi, John. This is Fabio. I mean, we can hear you. So you just, put the PowerPoint and try to, if you can, skip with the slide. See if, if it go okay.
Okay, so even though I can't hear anything, I'm all set to go.
Yeah, but I want to just try if the slide go ahead, because I can see your first slide. If you can, just for a try to skip some slide.
Okay, so I'll just all right. I'm just going to start talking about anything here, okay? And you can do what you have to do.
Okay, let's do that. Okay, so I will give you the floor, so you can start.
So just stay on the phone and then click one.
Okay, I can start the lecture.
Yeah, please just to click one to see if the works the slide. because I can see only the first page.
Second here.
Just for try. Yeah.
Hey, John, sorry. So he just wants you to click one over just to make sure
Yeah, okay, I just,
perfect.
okay.
So that's it.
I'm on, okay, did you get, okay, I just clicked the slide 3.
Good. Yep, go back to the beginning and then get started whenever you're ready.
Okay.
And he can chat with the student.
Oh, if
Okay,
you want
so-
to chat with the students on the text, you can. If there's anything that you see as you're going through, if somebody sends you a question or something.
Okay,
Okay, good. Perfect.
okay,
All right.
okay, so we're good to go right now then, right?
We are.
Okay.
All right, yeah, that's straight for us as well.
Okay, very good.
Okay, all right.
Yep.
All right. Talk to you later.
Okay. Okay, get started here. Good morning, good morning, good morning to everybody who's online. It's a session. My name is John Egan, and I am a retired LNG master. I've been in the LNG industry since 1979, and during that period of time, I spent 21 years sailing on board LNG carriers of the 125,000 cubic meter class, trading between Indonesia and Japan, Korea, and Taiwan. During that period of time, I spent 15 years as chief officer, cargo officer, and have handled approximately 250 loads, carriages, and transfers, discharges of LNG. Following my career at sea, of which the last 5 years were as master of carrier, I went into private business and spent years as a marine supervisor at the Minion Cove Point LNG terminal in Maryland, here in the U.S. Reactivation of that terminal, and during my stay there, we handled approximately 150 transfers of LNG. All of those cargoes were ported. After leaving Cove Point, I have worked as a independent consultant and advisor on numerous LNG projects internationally and within the United States. For the last 5 years, or the last 7 years now, I have been working for a company here in the U.S. on board their FSRVs, which is a floating storage and regasification vessels in Kuwait and Israel, and also with the United States in Boston. It's a LNG operation PIC. So I have been involved in the industry for a number of years, and have worked very, very closely with crews of international flavor. And all I can say is that for you students who are just getting involved or who will be involved in this LNG bunkering aspect of the LNG trade, entered the industry probably at a very, very exciting time. But it's also a time where we find ourselves with mixed, let's put it this way, mixed rules and regulations. The LNG trade has evolved, obviously, since 1969, when the first cargo of LNG was transported by ship. And over the years, the various operational procedures have been adopted initially by the industry. And this was Are we alive? Are we live again? Okay. Hopefully you can hear me. Initially, the industry it was kind of a self-regulate. We have a problem with sound. Okay. All right. Whoops. Okay, I'll keep talking. I'm going to keep talking here, and hopefully you're going to be able to pick up the sound. Okay, plug. One, two, three. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay now? Okay. Okay. Sorry about the technical difficulties. Let's see. Okay, good. So initially, because of primarily because of the large financial investment by companies who were getting involved in LNG, various procedures were adopted, and those procedures eventually were codified and endorsed by the international community and have become accepted international rules and regulations. So we find ourselves now. Okay, we've lost our. All right. Are we live again? Yes, we are. We find ourselves now at the early stages, at least internationally, of the bunkering aspect of the LNG trade. And as a consequence, we do have a different set of rules in various areas of the world. I saw a couple of comments when I was listening into the doctor giving the introduction, and okay.
Someone had made a comment that the rules were taken care of under the IMO through the International Gas Code. Please bear in mind the International Gas Code, or the International Code for Fuel, is regulates the construction of vessels that are going to be fueled by LNG, the construction of the vessel. The transfer process is an entirely different matter, and this is where we find the various rules and regulations. In the U.S., for instance, many of these bunkering operations will be covered by will be done by tanker truck. Now, in the U.S., tanker truck regulations are different than, it comes under a different section of the rules and regulations than the maritime does. Maritime obviously comes under U.S. Coast Guard. When you get into the trucking aspect of it, you have a totally different set of. So what we're seeing here now is we're going to see over a period of time, we're going to see a melding or a combination of these rules where everybody's going to sit down and we're going to get together, hopefully, and we're going to come up with a final set of rules that apply to just about all aspects of transfer of LNG as a bunkering fuel. So anyway, I wanted to make that clear. Hopefully I answered that question to the person who had it. And what we'll do now is we're going to right, 1, 2, 3, 1, 2, 3. Are we back online? Okay, hopefully you can hear. Okay. All right. Let's get started. Now, why are we even messing around with this, huh? This is LNG is going to be the future of fuel in the marine industry, and I don't have any doubts whatsoever. There's a couple of reasons that LNG has become the fuel of the future. One is its abundance, number one. Number two is the cost, less expensive than other marine fuels right now. But the primary reasons, or the primary drivers for LNG being used as a marine fuel, is environmental. Rules and regulations under the IMO MARPOL 6, we are seeing increasingly stringent environmental rules and regulations. And being responsible, it is only the proper thing to do is to minimize emissions from ships, which are a great source of pollution on a worldwide basis. So we've seen the establishment of emission control areas, sulfur emission control areas. Europe has been in the forefront of this, well ahead of the U.S. in the implementation of these stringent requirements. So consequently, the use of LNG as a bunker fuel has advanced further than the U.S. has. Though the U.S. now is in a rapid phase of catch-up, and we see LNG becoming very, very popular within the United States. Primarily in smaller vessels, tugboats, ferry boats, and now we see a couple of container ships being built in the U.S. which are going to be fuel-fired, and this will be the fuel of the future. So we'll take a look at LNG, properties of different marine fuels. Okay. What we're going to look at here in the overview of section 3.1 is the properties of our various fuels. Comparisons, and one of the easiest ways to compare fuels is to take a look at what are called marine safety data sheets. Every product in the world has what's called an MSDS. And this is an information sheet that tells you absolutely everything you need to know about a particular product. At some point, I will give you some references so that you can download one of these and take a look at what they are. But among the things that you're going to find on a MS that you'll find on an MSD sheet are the following bits of information. You're going to find out what the flash point is of the particular product, the flammability limits, characteristics, and then we're going to take a look at the characteristics of LNG with their relative emission comparison. And you did see a slide in the introduction, and you will see that again as we go along, so that we're going to be able to compare these fuels. Okay, move on to the next slide here, hopefully. Okay, our references are the McGuire and White liquefied handling principles on ships and terminals. This is a SIGITO publication, and for those who are not familiar with the acronym, SIGITO is the Society of International Gas Terminal and Tanker Operators, and SIGITO was probably the prime mover in the establishment of various rules and procedures, which eventually have turned into rules and regulations for the LNG trade. The LNG trade is a very, very well-regulated trade. It's probably a rule and a regulation for any possible thing that you think of. Okay. But as a consequence of this, the safety record for the carriage and transport of LNG, transfer of LNG has been remarkable. And you consider the number of movements of cargo over the years. And then the other reference that we have in here is also our safety data sheets, material safety data sheets. Okay, flash point. Flash point is the minimum temperature, and this is, I'll just read the definition, you can read along with me. The minimum temperature at which a liquid gives off vapor in concentration form an ignitable mixture with air near the surface of the liquid specified. Most of you, usually what we ignites initially is going to be a vapor. It's always going to be a vapor that exists. Just don't gasoline itself doesn't burn, it's the vapor that is. LNG does not burn. LNG does not explode. LNG is a cryogenic liquid at minus 160 degrees C. What happens is LNG will vaporize very, very readily, obviously, since it's so cold. That vapor, when mixed with air, particular concentration, form a flammable mixture. 5 to 15% by volume mixture of LNG air, item fuel. So you will find that minimum temperature for LNG igniting is very, very low, where it's really product. I will try, Shiara. Okay, is that better? Hopefully that's better. Let me turn the volume up just a little bit, hopefully, no. Okay, that's automatically adjusted. Okay, hopefully, okay. Okay, you're most welcome. Okay, so flash point's the minimum temperature at which a liquid gives off vapor in sufficient concentration to form an ignitable mixture with air near the surface of liquid as specified by test. Flammability limits. Okay. The concentration of the combustible hydrocarbon gas in air when the mixture is flammable, you have what's called the lower flammable limit, which can also be okay, back again. And then you have the UFL, or the upper flammable limit. For the case of natural gas, those limits run approximately 5% for the low LFL, 15% for the UFL. So any combination of air with a concentration of 5 to 15% of natural gas, you have a mixture that can burn. You take that mixture and you put it into a confined space, you now have the possibility of not only burning, but you also have the possibility of explosion. Unconfined LNG or unconfined natural gas doesn't explode. It does burn, but it explodes. You have to find space for possible explosion. Right. Okay, transfer of data here. Hopefully we're up and running again. Okay, we're still transferring this data to you guys. 1, 2, 3, 1, 2, 3, 1, 2, 3. All right. Okay. It's taking a little bit longer than I thought it would. What I'd like to take a look at next, this next slide, is going to be LNG compared to common marine fuels. The common marine fuels over the years basically are what's called bunker C. We hear you. I don't know what's happening, Chiara. I don't know what's happening. This information should be showing up on the screen here shortly. I have a the sending sharing. Okay, good. Okay. So the common fuels that are used, so let me, I'll run through this and we can take a look at this slide once this information gets thrown up onto the screen. Is your heavy fuel oil, which has been referred to as bunker C. This is a fuel oil that it's very, very thick, very viscous, and has to be heated to, approximately 150, 180 degrees. Okay, we've got the video back. And this has been the most commonly used fuel on board merchant vessels over the, some intermediate fuels, which are a little bit refined, a little bit better. But for the most case, your heavy fuel oil, your intermediate oil, 380 and 180. have the same characteristics. They have a flash point of about plus 60 degrees centigrade. They have a very, very high auto ignition temperature. That's the temperature at which it will ignite. If it just reaches that temperature, the fuel will ignite and burn. And they have a flammable range that's relatively, it's a little bit lower than what we normally find. It's about 1 to 6%. We could then go to a marine diesel oil, your marine gas oils. These are a little bit more refined product, but they're also a little bit more, they are more expensive. Less emissions than bunker C, but still a relatively high amount of emissions. And then we have our vaporized LNG, which has a flash point of minus 175. Minus 170. Don't believe that. I believe that's an error. I have to double check that. And I apologize for that. Okay, I'm going to okay, I'm sorry about that. I will double check that and get back to you on that. That's I don't believe that's correct. And you have an auto ignition point temperature of 595 degrees centigrade. So you can see there are some relatively big differences in how this particular product reacts, and what has to be done to it in order to use it as fuel. We'll quickly take a look at the relative emissions. And for some reason, we're not sharing this. I don't know why. Okay, you can see the PPT. Okay, all right. I'm not getting indication on my screen. Okay, thank you very much. And I will get that correct number for you. Okay. All right. Let's take a look at the emissions, and you did see a slide similar to this in the introduction to the course. And as you can see, what we're kind of looking at, and what is of great importance, are the NOx, which is your nitrogen oxides, your SOx, sulfur oxides, sulfur dioxides. Okay. Your particulate matter and your CO2. And the and what we're looking at is a reduction of all of these noxious emissions, and the improvement of our environment. And as you can see, the highest emissions are going to be from your heavy fuel oils. As we go into our MDOs, the marine diesel oil, which is a more sulfur emissions are still relatively high. Particulate matter is a little bit less. We can move on now to the LNG, which is your green green part of the graph. You can see that we have reduced nitrogens, your nitrogen, your NOx and your SOx, SO2, sulfur dioxide, and particulate matter. Sulfur dioxide in particular. CO2 is also reduced, so about 30%. So as you can see, emissions are greatly reduced. Yeah. Just accept. All right. Okay, good. Okay, we're off and running once again. Hopefully, hopefully we've got these issues resolved. LNG emission reductions compared to traditional diesel engines. You're going to reduce your volatile organic compound emissions by about 89%. Particulate matter is going to be reduced 90%. Reduce NOx emissions 85%. Reduce CO emissions 80%. And you're going to reduce your CO2 emissions by 80%. So you can see this is obviously a no-brainer, as we call it here in the U.S. Doesn't take a lot of doesn't right. Okay. Yes. Yes. Okay. You don't have to be rocket scientists, any one of us, to understand that by using natural gas as a source of fuel, we are going to greatly reduce emissions, and environmentally, this is a very, very friendly fossil fuel. You know, is it the ultimate answer to emission reduction? Probably not, but it will be an interim step when as we continue to increase our knowledge and technology. And once that's done, obviously we'll probably find much more fuel efficient and more efficient means of fueling vessels, as well as finding fuels that have even less emissions than natural gas. But I think for the foreseeable future, what we're going to be seeing is the use of natural gas on a worldwide basis. So keep in mind the definitions of deflammability. They are important. Properties of marine fuels and characteristics demonstrate a commonality and the differences, especially in emissions, which is the major point. The establishment of this is the platform on diversity force solve. I'm going to back up here just a little bit because these are important items, and yep, I will do that. Okay, flashpoint and auto ignition. Okay, flashpoint is the minimum temperature at which a liquid gives off vapor, sufficient concentration to form an ignitable mixture with air near the surface of a liquid as specified by a test. And this is determined under laboratory conditions. Okay. Auto ignition, and this is important, remember flashpoint. Oh, what? There we go. Auto ignition is if you heat this, if you take marine heavy fuel oil, if you heat it up to 160 degrees, 176 degrees, it will ignite. It will ignite. So that's the difference between auto ignition and flashpoint. Flashpoint is the temperature at which you get a vapor that if you get a source of ignition that will ignite. Auto ignition is the temperature at which it will automatically ignite on its own once it reaches that temperature. So bear in mind the differences between these two. Flashpoint being important as well as auto ignition. Okay? As we go through the course, please kindly note, if I say something's important, please take note of it, okay? This will be helpful to you when you get to Friday. All right. along here. Get into our second section. Okay. Properties of LNG. Well, we're going to take a look in this section, the components of LNG, properties, composition, characteristics of natural gas. We're going to take a quick look at what are called the gas laws, the ideal gas laws. Saturation pressures, flammability, vapor dispersion. Components of LNG. Okay, I hope you can see what's going on here. I've lost the... Okay, good. You see the slide. Thank you very much. Okay. Natural gas is found in many places of the world. It's a component of the degradation of fossil matter over the millennia. And the primary component of natural gas is methane. Combination of carbon and hydrogen, one carbon atom, and four hydrogen atoms. But very rarely are you going to find pure methane coming out of the ground. It's going to be mixed with other components of gas. And those components are going to be, you're going to find ethane, propane, butane, and then what are called heavy ends or condensates in very, very small quantities. Also, you're going to see a little bit of nitrogen, some carbon dioxide, some hydrogen sulfide, and helium. In the liquefaction process, your carbon dioxide is removed, hydrogen sulfide is removed, the helium is gone. A little bit of nitrogen is usually going to be left over, and keep note of that, make note of that, that there is some nitrogen in natural gas. But your primary components are methane, ethane, propane, and butane. We do have a slide coming up here. Oh, there we are. And these are your typical compositions that you're going to find throughout the world. Usually your methane is going to run anywhere from 85 to 87% up to as high as 99%. LNG coming out of one of the loading terminals in Egypt, I believe, runs around 99% methane. But most other parts of the world, it's going to be in the low 90s, upper 80s, and the balance is going to be made up of your other components, your ethane, propane, and heavy. Heavy ends are usually a very, very, very small amount, less than 1% of total volume. You may find up to 1% nitrogen in a cargo of liquefied natural gas. So natural gas is going to be predominantly CH4 with small quantities of these other components, ethane, pentane, propane. It becomes a liquid at minus 162 degrees at atmospheric pressure. your LNG tankers in the international trade, the cargo is carried at approximately atmospheric pressure, slightly a little bit above, but atmospheric pressure for all intents and purposes at around minus 160. Okay. Carriage conditions, atmospheric pressure to 10 bar. Okay, you're going to find these higher pressures with a particular type tank. Internationally, there are two types of tankers that are used, and those, as I said, you're going to carry the LNG at atmospheric pressure. There are some smaller vessels. Pressure is we allow this cargo to boil, and we'll get into this in a later section, and that keeps it cold. You'll see the temperatures, and then minus 161, minus 160, minus 1. Okay, good. We're up and running again. And the density of the cargo is going to be anywhere from 470 kg per meter cubed, it's 3 meter cubed, to 360 kg per. Normally it's in this little bit higher range as to typical LNG cargo that you're going to find on an LNG tanker. Okay, transportation and storage of LNG. Supertanker, LNG carrier, most of these ships range in the 100,000 ton range, about 300 meters in length. And this is your typical tanker. The upper right-hand one is a spherical or a Moss tanker. These are your round tanks. And the lower graphic here is a membrane tank, which is another type. I'm not going to take a look at these videos at this particular point in time. I'm going to look at them at a later portion of the course because it kind of fits in a little bit better. But we do have a video where you're going to actually see the inside of one of these spherical tanks and what it's like, and you'll also see the construction of the membrane tank. Two totally different type systems, but they're the most commonly used in the world. We're probably looking at something like 500 ships in international trade now. I'm pretty sure we're up into that range. And these ships are very, very sophisticated, very, very robust in their construction, and have a safety record that is probably the envy of the international shipping industry. And that safety record is a consequence of a safety culture. You'll hear me referring to this probably quite frequently as we go through this course. And it's a trade that has that does have a culture of safety, and hopefully we're going to see this culture carried over into the bunkering aspect of the LNG industry. I will be talking a great deal about LNG tankers because there are various means to bunker vessels, and one of the means that's going to be used is going to be a small LNG tank. And the procedures and regulations that these vessels are going to use are going to be identical to those that you find in the international trade. When we get down into the smaller barge operations and trucking operations, this is where we're going to find some of the differences between the maritime rules and regulations and the regulations for smaller vessels. This is probably the area that eventually IMO is going to come up with a standard set of rules and regulations that everybody's going to have to follow. But until that point in time, we're going to have these differences and variations. But it is important to know how the LNG tanker trade operates, because I do believe that these are the rules and regulations that ultimately are going to be adopted for this part. Okay, the LNG has to be cooled to approximately minus 160. Cool, compress, cool, compresses. And at minus 160 degrees, it becomes a liquid. And at that point in time, it consumes 1/600th of its original volume. And this is what makes the transport of LNG by vessel feasible. Otherwise, obviously, it couldn't be done. If you were trying to transport a vapor, first of all, you couldn't build a ship big enough. You can't build pipelines big enough to transport the volumes that we're talking about. So we take this product, we cool it down to minus 160. It takes on to form 1/600th of its original volume, and we now find it economical to transport, handle, and use. At the ambient temperature, because the ambient temperature obviously is much higher than the liquefaction temperature of LNG, the liquid is always boiling. And probably the best comparison here is just think of a pot of water that you put on your stove, and you heat it up and it begins to boil. And this is what actually an LNG liquid will look like inside the tank of the ship. It's constantly boiling. At the surface, the liquid is turning to a vapor, and as it turns to a vapor, it removes heat from the environment, and that removal of heat keeps the liquid cold. So it's always in this process of boiling and cooling, boiling and cooling, boiling and cooling. The LNG becomes a vapor at approximately minus 110 degrees centigrade. It's colorless and it's odorless. At that temperature of minus 110 degrees, the vapor is actually denser than air. It's heavier than air. So when there is a release of LNG as a vapor, that vapor will stay close to the ground initially at minus 110 degrees. When it gets a couple of degrees cooler, then it becomes less dense than air, and it begins to rise. The vapor is odorless and colorless, but we say the vapor can be seen as it mixes with air, because what happens when the LNG vaporizes, it will condense the water vapor in the air, and it turns to a fog. So if you do see a leak or a leak of natural gas, you're going to see this looks like steam, and where you see that steam is actually, it's LNG vapor, but that's actually water vapor that's condensed in the air that you're looking at. It's not the natural gas. That's how we get the white cloud. So remember your properties of LNG. Important. It's odorless, colorless, non-toxic, non-corrosive, cryogenic. Cryogenic meaning it's a very, very low temperature liquid, 2 degrees atmospheric pressure. Okay. The property of non-corrosive is very, very important, obviously. You don't have to worry about it destroying tanks. We have vessels out on the ocean that are 40 years old, still operating with the original tanks that the vessels were built with. And going inside an LNG tank is an experience I wish you could all have, because it's very, very interesting. But it's also interesting to note that when you go into a gas-free LNG tank, it's clean. It's perfectly clean when you go inside the tank. Unlike an oil tanker or a product tanker or whatnot, where you're going to get a lot of sludge and leftover product and whatnot. It's usually very, very messy, very nasty. When you go inside an LNG tank, it's perfectly clean. Okay, character again. Run by this. When cooled to minus 162 at atmospheric pressure, it condenses into the liquid. And it's stored as a boiling cryogen. As we mentioned, it's just like a pot of water that's heated up to 100 degrees, and it boils. And this is what the LNG does. It boils. It's very cold liquid at its boiling point, which is about minus 160 degrees at atmospheric pressure. The temperature of the boiling water, I'm going to run back to that analogy, doesn't change even with the increased heat. It's cooled by the steam evaporating from the surface, cooled by the natural gas evaporating. It stays at a constant temperature, kept at a constant pressure. The process is known as auto-refrigeration. So if someone someone asks you, how does this stuff stay cold? You just say it's allowed to boil. It just auto-refrigerates. And you can use this analogy that we've used with boiling water. It's just that it happens at a much colder temperature. So as long as the LNG boil-off vapor is allowed to leave the storage tank, temperature will remain constant. You have to allow this to boil when it's on board the carrier vessel. There's a phenomenon that LNG is unique to LNG, and it's called rollover. And this is something that a vessel doesn't worry about. The vessel is a dynamic platform. But it is a concern for shore tanks. So as LNG weathers, the density increases due to the higher percentage of ethane and propane in the mixture. And how does that happen? Well, the natural gas, the methane, boils off before these other components of gas do. Minus 160 degrees for your natural gas, and your ethane starts to boil. I believe it's around minus 80, something like that. So the ethane and propane and these other heavy ends are going to stay liquid longer because they boil at a much higher temperature. So as the as the methane boils or leaves the product vapor and product at a higher concentration of propane. So if you're filling a tank, shore tank, and you bottom fill it with a lower density, colder, unweathered LNG, you can cause a stratification, and you get a heavier layer of weathered LNG forming above a less dense lower layer. The tank can stay in this condition for a while, but eventually nature wants to take its course, and this lighter stuff, the lighter stuff, which is at the bottom, wants to come to the top. And it can do this, and it does, and this does happen in a shore tank if they're not properly contained. So if this condition is allowed to happen, and you do get this phenomena where the heavier layer, which is formed above the less dense lower layer, they flip. And when this happens, you get a tremendous increase in pressure in the tank. And this pressure increase can be such that it will damage the tank. So this is a concern. So it's important for the shoreside personnel to pay attention to how your tanks are loaded and how the cargo is transferred from tank to tank, and the pressures and temperatures are monitored at all times to prevent this from happening. So the rollover is a spontaneous mixing that takes place to reverse. It's an instability that you have in the tank and results in a rapid release of boil-off vapor. And as I said, it usually occurs in shore tanks where there's no dynamic forces to cause mixing. I'll touch briefly on the gas laws. I'm a sailor, folks. I am a sailor. I'm not a chemist. I'm not a physicist. If your background is in this area, please bear with me. I'm just going to briefly go through how gases react under ideal conditions. There is no such thing as an ideal gas. However, there's relationships that have been described that explain the phenomena that we observe in the handling of LNG boil-off, and also with all other gases. With LNG boil-off, if you have an increase in temperature, product temperature is increased, there's going to be an increase in pressure. If you decrease the temperature, there's going to be a decrease in volume. And if you increase the pressure, you're also going to have a decrease. One of the first gas laws is a law called Boyle's Law, and this applies to gases at a constant pressure. Volume of gas is inversely proportional to the absolute pressure. As you can see, as the pressure increases, volume increases. This will hold. Charles's law applies to gases at constant pressure. We're going to maintain a constant pressure, and as the temperature increases, volume increases, as the temperature decreases, volume. This is what happens. You put an empty soda bottle in the freezer. It reaches the freezer temperature, that bottle eventually collapses, plastic bottle. And your pressure law applies to gases at constant volume, temperature, increase the temperature, increase the pressure, decrease the temperature, decrease the pressure. Saturation pressure represents common, solids, liquids, and gases represent the common states of matter. Latent heat is required to change the state or phase. Temperature remains the same during the phase transition. And that is indicated by the graph that we have. We have a solid, we increase the temperature, eventually it reaches a point. That solid is going to transfer from the solid into a liquid. We keep adding heat. This is latent heat. And at that point, transfer, the solid, the temperature is going to remain the same. So we reach a point in temperature, we continue adding heat, The temperature remains the same, and then we get this change of phase to a liquid. When the change of phase takes place, we continue to increase the temperature. The liquid temperature continues to increase. And again, we reach the phase where we're going to change our phase from liquid to vapor. Again, adding heat, latent heat, vaporization or condensation. Vaporization going from the colder to the, going from solid to a liquid to a vapor. And it's condensation, we're going to do the reverse there, okay? So we keep adding heat, Eventually we reach the point where it changes over to a vapor. And again, the temperature increases after that. And this is what happens to the LNG. We have a saturated vapor. Vapor phase that is in equilibrium with the liquid phase. In other words, once we reach that point, this is at that boil-off point inside the tank. The vapor phase, changing from liquid to vapor, vapor to liquid, it's transferring back and forth as the temperature increases, changes over to a vapor, when it changes over to a vapor, we're withdrawing latent heat, so we actually get some phase change back to a liquid. And this is the process that's taking place at the top of the tank. And this is the saturated vapor, the saturated pressure of the tank. Liquid and vapor phase are at the same temperature, and saturation depends upon the temperature and pressure. The pressure of saturated vapor is at a specific temperature as saturated. Different gases have different saturation pressure. So the LNG is going to be, this temperature and pressure will be totally dependent upon the composition of the product. This can vary from transfer to transfer. Each time you get the LNG, it's going to be a little different. That was probably one of the most interesting things about working with LNG over the years. We used to load cargo. Sometimes we would load cargo at the same port time and time again. And people would say, well, gee, doesn't that get boring? It's the same stuff. And the answer to that question was absolutely not. Every time you loaded a cargo, the cargo was a little bit different from the cargo before. Every time you carried that cargo, it reacted differently from the cargo. So each time you handled the product, it was a little bit different and presented different challenges. And this obviously made it an interesting product to work with. We used to refer to it even, it's from the fossil decomposition of the fossil, fossil whatnot. So, it's a dead product, but no, it isn't. We used to call it a living product. It did change. It's always changing. Even as you carried it, the product is changing during the entire transit. So it becomes an interesting product to work with. Really? Flash to its gas phase. An increased pressure will cause the gas to condense to a liquid phase. And this is the process that's taking place the entire time that you have this cargo on board your vessel as a fuel. So as a consequence, we have to constantly monitor temperature and pressure. Who's keeping an eye on these things? It's not like carrying bunkers where you just loaded it's not like carrying bunker C or MDO or MGO. You just dump a cargo into a tank. Okay, you take your soundings. You know what quantity of cargo you have on board there, and you measure the level of the liquid in the tank. With LNG, it becomes a little bit more complex. Let's check this again. And here's a graphic of saturation pressure relationship between temperature and pressure. And you can spend a little time looking at this, and you get maybe a little bit better understanding of what we're talking about. Okay. Temperature scale, and this is your pressure scale. Absolute. We're looking at latent heat of vaporization, vapor pressure, liquid density, and saturated vapor density. And you can see the correlation and relationship between temperature and pressure for each one of these characteristics. Okay, methane flammability in air. Again, this is important. You always want to be aware of this. Lower explosive limit, 5% methane concentration. Below this concentration, mixture is too lean to burn. It will not burn. Upper explosive limit, or your upper flammable, these acronyms can be used interchangeably, UFL, UEL. It's 15% methane concentration. So anything between 5% and 15% of methane in air, you have a flammable mixture. Below 5%, it's too lean to burn. Above 15%, the mixture is too rich to. This is very much akin to the thing that we've probably all seen, where someone will put a match out or a cigarette out in a can of gasoline. If you can get that match or that cigarette through the vapor quickly enough and into the liquid, it will extinguish. Same thing with the natural gas. Of course, you're not going to be putting cigarettes out of it, obviously. But the fact of the matter is it's the same. If it's too rich, you're not going to get any ignition, and if it's too lean, you're not going to get any ignition. So remember that 5 to 15% concentration in air. Also, when we're looking at this possibility of ignition and fire, we have to have oxygen, obviously. So we have a limiting oxygen concentration. The acronym for that is LOC, 12% oxygen. You have to have at least that. Anything below that, you have insufficient oxygen. An inert atmosphere is less than 5% oxygen concentration. Onboard LNGs, and this will be emphasized in one of the latter sections. There's two things. There's something that you would never allow to happen at all. Never allow methane to mix with air. There's always going to be an intermediate step. And that intermediate step is going to be an inert environment. Inert meaning exactly what the word means. It's non-reactive. So you have to have an intermediate step where you have an environment where if methane gets into it, nothing is going to happen. And on board the ships, anything less than 5% oxygen concentration, and in most cases it's less than 1% oxygen, you have an inert environment. So the differences between the LOC and an inert atmosphere allows for incomplete mixing of gases and instrumentation. On board ship, always much more conservative than what some of these books allow or rules and regulations allow. You're always going to be more conservative. So as I said, usually in an inert environment on board the ship, be that in the tank hold where the tank is contained, or in the inner barrier spaces, you're going to find a product in there that's probably less than 1% oxygen. In most cases, we use nitrogen, so we're talking about 99.5% nitrogen in space. So you do get any methane mixed into that. You do not have sufficient, there's no oxygen, so you will not have ignition, you will not have fire. We'll take a look at, in the next slide, is going to be the flammability diagram. It's used to determine if a mixture of oxygen, nitrogen, and methane is flammable. So, the air that we breathe is approximately 21% 21% oxygen, 79% nitrogen. As methane is added, the percentage of oxygen and nitrogen increases, the atmosphere. The ratio is constituent gases over the range of concentration. The airline, the LEL, and UEL fall on the airline. When commissioning or gas freeing a tank, the mixture must stay outside the flammable envelope. Okay, and this is the flammability diagram. Okay. Anything in this area, any mixture in this area is going to be flammable. There's your LEL right here, 5%. 5% as we work it up to okay. All right. Flammable mixture. Start out with 5% methane and work your way up. 60% methane. Mix with oxygen and nitrogen. So anything in here, you're going to find that is a flammable mixture. So these are the things that are going to be monitored when we're conducting operations on the ship, where you're changing over from a methane environment. You eventually want to get to a full air environment. The easiest way to do that is just totally minimize any mixture of air whatsoever by keeping that intermediate step in there, you go from methane to an inert environment, totally inert, and then you will introduce you will introduce oxygen into the space. Once you have all of the methane out of it, once the methane concentration is, say, less than 1%, you are dealing with the remainder is an inert environment, then you will start introducing air. So these procedures that are followed very, very closely, you do not have the possibility of mixing methane with any quantity of air that could become a flammable mixture. The important thing is to remember that 5 to 15%, the intermediate step of maintaining an inert environment. Going quickly through vapor dispersion. Let me look at my clock here. 6, 12, 12. All right. LNG spills. An LNG spill is going to result in a vapor cloud, which is going to disperse in a downwind direction. Only a portion is flammable due to the varying gas concentration and on ignition. If there is a source of ignition, flame will propagate to the source. We'll be able to see some pictures of this. Okay. This is a typical vapor dispersion diagram that's used, right? You have a spill at point A here. Initially, you're going to have this area where the concentration of methane in the air is over rich and nothing is going to happen. You're not going to be able to ignite it. But as this methane mixes with air, you now reach this point where area C, where this mixture becomes flammable. And this is that area where you have from 5 to 15%. 5% would be out here on the outer edges of it, and as you work closer to the source, once you go beyond that area of 5%, the mixture is too lean. So if there's any source of ignition here, nothing is going to ignite. If you have a source of ignition in this area, it will ignite, and then it will burn back towards the source. Okay, here's your wind direction. The cloud is moving in this direction. So this is how a vapor cloud disperses. It's going to be It's going to be wind dependent. It's going to be environmentally dependent. There's buildings in here. Obviously, it's going to change. It's going to change the way this cloud disperses. And these studies are conducted. We conduct studies whenever a facility is sited, wherever you're going to get the storage or transfer of LNG. Local regulations, rules and regulations are going to require that a vapor dispersion simulation be done. And this is critical to any LNG operation. Okay. Up and running again, back online. Okay. Okay, so working with LNG is it's predictable based on proven principle. Okay, very, very predictable product. So we monitor the condition of the product at all times. It's on board the LNG temperature, constantly monitoring the temperatures, pressures, densities, and by doing so, you know exactly the state of the cargo at all times. And it's going to be very, very similar when you're carrying LNG as a bunker, as you're bunkering fuel. As long as you follow the proven principles, you can know exactly what this cargo is going to do. The ability to lower its temperature allows for increased storage at terminal and or on vessels. LNG requires high performance technology and safety procedures. Safety, safety, safety. Again, harp on safety throughout this entire course. Safety is just so very, very critical. LNG is still looked upon by the general public as an extremely dangerous product. It is a flammable hydrocarbon. What it is. It's all it is. There are vessels out there carrying products that are much, much more dangerous and volatile than LNG, and very, very little attention is paid to them. But for some reason, LNG is always in the forefront. So because it's in the forefront, it's necessary for us, people who are going to be handling it, using it, to become very, very safety oriented. Safety awareness is absolutely critical and key. Safety and performance depend upon the understanding what is. A lot of myths out there about LNG in society. We still have people believe that an LNG tanker is capable of exploding all at once and having the explosive force of God knows what, 50 atomic bombs and all this other stuff. That may be potential energy, but that's what it is. It's potential. It's not going to happen because it can't happen. You have to have certain conditions under which LNG burns, under which LNG explodes, and those criteria are never going to be met on board a ship. Okay? So it's important to understand what the myths are. There's a lot of, like I said, there's a lot of myths out there, make-believe stuff. So it's incumbent upon us as instructors, upon you as students, upon you who are going to be involved in the LNG bunkering operation, to fully understand exactly how this product acts and reacts under all circumstances, and knowing that when handled properly, when handled the way it's supposed to be handled, is a perfectly safe product, and it can be utilized to full advantage because of that. Okay, let's see here. I do believe it's almost 12:30 in Sweden. Now almost 6:20 here on the east coast of the United States, and I think what we'll do now is we're going to take our lunch break, and we'll be back at 13:30 Sweden time, which is about an hour and 10 minutes from now. So thank you for your attention. If there's questions, the moderator is going to get those questions to me. I will double check that flashpoint temperature that was incorrect on the slide, and I'll get back to you with that information. And as we go along, I'm going to try to get information to you on how to download one of these material safety data sheets, so that you can take a close look at one of those and understand the information that's available from one of these sheets. Like I said, all products have an MSDS sheet, and it's important that when you have LNG on board the ship, that you do have the latest data sheet. What's actually even more important than a data sheet with the LNG is the composition of that particular cargo. Because the data sheet for methane is a pretty standard document. What you're going to be most interested in addition to that, is the actual composition of the product that you're loading on board the vessel. That's what you want to know. You want to know how much methane is in there, how much propane, how much ethane. This is information that we'll get and transferred to you prior to the transfer of the cargo ship. Okay, so I'll try to get those items to you. Once again, if the moderator does have questions, they will get them to me, and I'll try to make any clarifications that are necessary, and we'll move on to. Thank you very much.
Hi, John. Jared here.
Yeah, Jared.
Nicely done. Thank you. Yeah, 13:30 will return. If you want to send over those documents, if you have them available, we can then send them out to the student emails that we have.
Okay. All right. Good. I'll do it that way.
Okay. And then the other thing is, for the students that are still here, just a reminder, we will be posting the PowerPoints, and I think what we decided to do is to give you all of the PowerPoints for the week, so that you have them in front of you for the rest of the week. But that won't come until the end of the day or later on today. But by the evening time, you should have access to all of those.
All right. Okay. Good job.
We'll give you some direction on how we are posting those, but I think it's through this platform. Okay, so we'll see everybody in about an hour and 10 minutes. All right, thank you.